Everyone. Our project for this year's hackathon is indoor navigation. In our daily life, we've been to so many places, including very complex buildings such as hospitals or shopping malls. And then sometimes we get lost in this kind of building because, for example, maybe we don't know where to go to find our favorite restaurant when hanging out with friends. And sometimes it takes us forever to find like our doctor's office. However, with our team's indoor navigation method, maybe the above problems may be possible to solve. Why indoor navigation is so challenging? Because first of all, we have limited GPS reception in the building. And then some buildings are pretty complex. They may have like several floors or like every floor have like many rooms. And then there may be some signal interference and also the battery consumption. And then so we developed a method to try to resolve the limited GPS reception problem within the indoor building. This is called Wi-Fi positioning. So basically, we use like deep learning and then transfer like the area within like XY coordinate to determine the relative distance from the device to the Wi-Fi router. So and then we store the following information in each dumps to let the Python analyze it. So we observe the surroundings and then determine the location of our agent using the XY coordinate. And also we consider the rotation by like dividing the rotation in one of the four cardinal directions, 0 degree, 90 degree, 180 degree, and 270 degree. And then from this information, we create a state action transition graph to like identify the location on the computer and then indicate like the collision. And also, we could find the shortest distance to like reduce amount of time walking. So to do this, we create a square matrix of the shortest distance between pairwise locations where negative 1 means two states are unreachable from each other. And then we put all of this data into a CSV file, and then we could use Python to analyze it. So based on this technique, we developed like two separate methods for like young people and disabled people. For young people, we create the AR indoor navigation, which is basically augmented reality indoor navigation, and then we use marker-based method. So it's like you scan QR code and then it tells you like where you are now, and then you input the destination and then the map will like guide you to the destination. However, this method has its drawbacks. For example, like the patterns may get dirty over time and also the QR code may become invalid. And then for old people and disabled people, maybe I develop a robot navigation, like the camera is embedded in the robot, and then it can obtain the viral paths. So the viral path is stored in the robot, and then when like the old people, and then they tell the robot the destination, the robot can guide their way. So our solution is a blend of robot navigation and AR navigation. For example, in a shopping mall, we could provide robot navigation for old people, and then we could design a phone app for young people. So we put the 3D map in the app and then enable the phone to use the camera of the phone to scan the surroundings instead of a certain QR code or sign. Because signs could become dirty or blurry over time, and QR code could also maybe have the risk of becoming invalid. To complete this, we could use Python to grasp images and do deep learning. Then on the app, we could use arrows to better navigate the way. And also, one of the special features of our app is that we install detector at every room in the shopping mall so that on the app, it can show that how many people are in the same room. Then maybe, for example, like there's a very popular restaurant and many people want to go there. So, but they can know if this restaurant is busy currently beforehand. So they could decide whether like to go to the restaurant or not. Maybe they are just like in a hurry, like they're too busy. Maybe they can like choose to go to the restaurant next time.